What is the Coanda effect in fluid mechanics? Imagine pouring a stream of water from a glass and watching it cling to the side of the glass as it flows down. That simple act actually demonstrates a fascinating principle in fluid mechanics called the Coanda effect. This phenomenon occurs when a fluid jet, either a liquid or a gas, tends to stick to and follow the shape of a nearby surface, even if that surface curves away from the original flow direction. It might seem like magic, but it's all about how the fluid interacts with surfaces through forces like viscosity and pressure differences. When fluid flows along a surface, the layers of fluid right next to the surface experience friction, which slows them down. This slowing creates a pressure difference between the layers of fluid close to the surface and those farther away. The pressure near the surface drops, pulling the fluid toward the surface and causing it to bend and stay attached. This attachment continues even when the surface curves away from the initial flow path, making the fluid follow the surface's shape. In terms of fluid flow regimes, the Coanda effect is closely related to how fluid jets behave near boundaries and surfaces. It influences flow attachment and separation, which are key in understanding how fluids move in different situations. For example, in wall jet flows where a jet moves along a solid boundary, the effect impacts how well the flow stays attached and how it mixes with surrounding fluids. It also affects pressure distribution and momentum transfer in the flow, which are important in many engineering applications. In practical terms, the Coanda effect is used in many fields of mechanical engineering. For instance, in aerodynamics, it helps improve the lift of aircraft wings by guiding airflow over curved surfaces. This makes wings more efficient and increases the lift they generate. In internal combustion engines, it helps with exhaust scavenging by drawing gases out more effectively. Fluidic devices like flow control valves and amplifiers also relying on this effect to direct fluid streams without moving parts. Even in racing cars, especially Formula One, engineers design car surfaces to take advantage of the Coanda effect. They shape the bodywork to guide airflow in a way that increases downforce and reduces drag, helping the car stick to the track better and go faster. A common everyday example is when tea or coffee runs down the side of a teapot spout instead of flowing straight down, thanks to the fluid sticking to the surface. Understanding the Coanda effect is essential for mechanical engineers working with fluid systems. It shows how viscosity and pressure gradients shape fluid flow near surfaces, influencing everything from aircraft design to everyday objects. This effect highlights the importance of surface shape and fluid properties in controlling how fluids move and behave in different environments.